For topic 4, we're going to look at solving systems of equations in two variables using the addition method. Now, some books will call it the addition method. Other books will call it the elimination method. I call it either interchangeably, okay? So just know that they both mean the same thing, okay? Now, this method involves converting the system to one equation by eliminating one variable when adding the equations, okay? That is a lot. So we're eliminating one variable when adding the equations. That's why this is called the addition method. This is sometimes called the elimination method because you're eliminating a variable when you add the equations, okay? So this one can be a little tricky for students, but once you get the hang of it, it's really not bad. This is probably my preferred method. This is the one I tended to use the most as I was learning this. So I'm more comfortable. I mean, I guess I'm comfortable with both, but this is the one I tend to go to more often. But you can do either one, okay? And you'll find that as you're solving these equations, you'll start to recognize when one method is going to be easier depending on the type of system you have, okay? Now, to do this, if necessary, and this is not always a necessary step, it just depends, but if necessary, write both equations in standard form, okay? You do want your equations in standard form, meaning the x term first, the y term second, and then the constant after the equal sign, okay? Now, after that, the next step you sometimes have to do to both equations. Sometimes you have to do it to one equation. Sometimes you don't have to do it at all. Just depends, okay? But for step 2, if necessary, multiply one or both equations by a non-zero constant so that the coefficients of one variable are opposites. Okay, now remember, our whole goal is to eliminate one variable when we add the two equations. And in order for things to cancel out when we add them, they would have to have opposite coefficients. So imagine having something like negative 3x plus 3x. Well, you can see the coefficients on x are opposites. We have negative 3 and positive 3. So when we add these, we end up getting 0x or just 0. Okay, so we could eliminate a variable as long as that variable had opposite coefficients and we could add the two variable or add the two equations together. Okay, so again, our goal is to eliminate one variable by adding the two equations. For this to happen, that variable has to have opposite coefficients. And in order for this to happen, you can multiply all of one or both equations by some non-zero constant. Okay? Now, once you have it figured out where one of the variables has opposite coefficients, then you just add the two equations. So you add the x terms, the y terms, and the constants, and one of those two variables will cancel out, giving you an equation in one variable that you can then solve. So after you do that, you would solve for whatever is left over. That's going to give you one of the two variable or one of the two coordinates of your ordered pair. Plug that value back into either original equation to get the second coordinate. You've got your ordered pair solution. You can then check your answer. Okay, so just like before, saying all that in words may not make a whole lot of sense, but I think once you see it in practice, it'll kind of make more sense what we're saying. Okay, so example 4 says solve each system of linear equations using addition. Write the answer as an ordered pair. Okay, so we have 2x plus y equals 14, and then we have 4x minus 7y equals negative 8. Okay, they're both in standard form. You do want to always make sure your equations are in standard form. And then you want to look to see, is there a variable that is already going to cancel if you were to add these equations? So if I were to add these equations, 2x plus 4x is 6x. That doesn't cancel. 1y minus 7y is negative 6y. That doesn't cancel. So we're going to have to do some work. And it is totally up to you which variable you want to get rid of. For me, I can look into the future and I can see that getting rid of y is going to be a little bit quicker, okay? So if we choose to get rid of the y, we only have to multiply one equation, okay? So if we get rid of the y, I could multiply the entire first equation by 7. And here's why. If I multiply the entire first equation by 7, I end up getting 7 times 2x, which is 14x, 7 times y, which is 7y, and then 7 times 14, what is that, 90 something? 98, I might be lying. 14 times 7 is 98. I wasn't lying this time, yay me. So if we multiply the entire first equation by 7, 14x plus 7y equals 98. If we leave the second equation alone, we end up with 4x minus 7y equals negative 8. And look what happens. When we add these two equations, 14x plus 4x is 18x. Negative 7y plus 7y, or 7y minus 7y, however you want to look at it, is going to cancel. That just becomes 0. And then 90 minus, or 98 minus 8 is 90. So then we could divide both sides of the equation by 18. 18 divided by itself is just x. And then 90 divided by 18 is 5. All right, so by multiplying one equation, we were able to get rid of one of the variables. So now I'm like, okay, well, I've got x equals 5. What do I do with this? Well, I can take this value for x and plug it into either of the original equations for x. So let's say we plug it into the first equation. So I would get 2 times x, where x is 5, plus y equals 14. Well, 2 times 5 is 10, so I get 10 plus y equals 14. I want to get my y alone, so in order to do that, I would need to subtract 10 from both sides. So 10 minus 10 is 0, 0 plus y is y, and then 14 minus 10 is 4. So we now have a value for x, we have a value for y. We want to write our answer as the ordered pair 5, 4. So this right here is our solution, okay? Now, for fun, let's say you didn't realize that you could easily get rid of your y's, and you were like, I'm going to get rid of my x's. That is fine. We could do that, okay? So if we wanted to get rid of our x's, it would still just be a one-step process. Let me make some room here. So notice here for the x's, if we wanted to get rid of the x's, I have coefficients of 2 and I have coefficients of 4. So 2 and 4, those are my coefficients. If I add these two equations, I want to force it so that the x's have opposite coefficients of each other. That way, when I add them, they'll cancel. So I could take this top equation right here and multiply it by -2. So let's see what happens when we multiply that entire first equation by -2. Well, -2 times 2 is, or -2 times 2x is -4x. -2 times y is -2y. -2 times 14 is -28. And then the second equation, I'm going to leave it alone. I get 4x minus 7y equals -8. Now remember, the whole idea here is to eliminate a variable by adding the two equations. So now when I add the two equations, -4x plus 4x is 0. -2y minus 7y is -9y. And then -28 minus 8 is -36. So I want to solve for y. In order to do that, I need to undo the multiplication of -9 and y. So I divide both sides by -9. The -9s, when I divide them, they just become 1, leaving me with y. And then on the right, -36 divided by -9 is 4. And that should look familiar because remember, our solution, we already solved this one. We got 4 for y. Now that's all well and good. We want to take this value for y, plug it into either of the two equations. It does not matter which equation you plug it into, just one of the original equations. So let's say we plug it into the first equation, so we get 2x plus y, which is 4, equals 14. Now I want to get my 2x alone, so I would need to isolate the 2x. To do that, I would subtract 4. 4 minus 4 is 0, leaving me with just 2x. And then 14 minus 4 is 10. So I need to undo the multiplication of 2 and x. To do that, I divide. Well, 2 divided by 2 is 1. 1 times x is x. And 10 divided by 2 is 5. So again, that should look familiar. All right. So you don't have to solve these equations twice, or these systems twice. Pick one. I am only solving this one twice to show you that you can get rid of the y or you can get rid of the x. It doesn't matter. And you'll get the same solution. So even over here, we get 5, 4. All right. So from now on, we're just going to solve using one variable. We'll eliminate one at a time. Okay. But just know that you can get rid of the x or you can get rid of the y. It doesn't matter. You'll get the same answer at the end of the day. Okay. So let's look at part B. So we have 5x plus 3y equals -2. And then we have -3x plus 6y equals 9. Okay. What is nice about looking at the y's is 3 divides into 6 evenly, okay? So 3 divides into 6 twice. So if I multiply the top equation by 2, I would get 10x plus 6y equals -4. And then the bottom equation is -3x plus 6y is 9. So we'd be halfway there. If we could multiply that top equation by 2, we would get the same coefficient. But remember, we don't want exactly the same coefficient. We want opposite coefficients. Okay? So if I wanted to get rid of the y's, I could multiply the entire top equation by -2. Okay? By multiplying the entire top equation by -2, I would get -10x minus 6y equals 4. And then the second equation would stay the same. -3x plus 6y is 9. And if I were to add the two equations, my y's would cancel, leaving -13x equals 13. And we could keep going. Okay? Now, I'm not going to solve it this way, even though this way would be the quicker method. I'm actually going to show you how to get rid of the x's. Okay? Just so you know how to do this when you have to multiply both equations. Okay? So let's do the other one. So again, if we got rid of the y's, it would actually be quicker, but I want you to see how you multiply both equations. Okay, so in this case, we want to get rid of the x's, okay? They have coefficients of 5 and -3. So the good news is one coefficient is already positive, the other one is already negative. So you're not going to have to worry about signs, but you do need to force these coefficients to have opposite you want to force these coefficients to be opposites. So they need to have the same coefficient, just one positive, one negative. Okay? So here's what you do. If you are in a situation where you have to multiply both equations, ask yourself, what is the smallest number 5 and 3 divide into? Okay? So the smallest number that 5 and 3 divide into would be 15. Okay? So then you want to force the coefficients to be 15 and -15. Okay? So in order for that to happen, we can multiply the entire top equation by 3. And then because we already have negative on the second equation, we can multiply the entire second equation by 5. And here's what's going to happen. When we do that, the top equation becomes 15x plus 9y equals -6. The bottom equation, when we multiply it by 5, we get -15x plus 30y equals 45. Okay? Now, when we add the two equations, the x terms will cancel. So again, it would have been quicker to get rid of the y. I just wanted to show you how you handle it when you have to multiply both equations. Okay? So we add the two equations. 15x minus 15x is just 0. And then 9y plus 30y is 39y. And then -6 plus 45 is 39. Okay? So in this case, let's see, we want to divide both sides by 39. Okay? 39 divided by itself is 1. 1 times y is y. And then 39 divided by itself again is just 1. So we can say now that y is equal to 1. Okay? Now we need to use that to figure out what x would have to be. So I can take this value for y, 1, and I can plug it into either of the original equations. It legitimately does not matter which one. Let's say we choose the second equation. So anywhere we see a y, we're going to replace it with a 1. So let's see, we get -3x plus 6y, which is just 1, equals 9. So that's going to be -3x plus, well, 6 times 1 is 6, and then that still equals 9. We want to get the x term alone. The issue is this 6, so I want to move the 6 with subtraction. So I subtract 6 from both sides. 6 minus 6 is 0, leaving me with just -3x equals, well, let's see, 9 minus 6 is 3. I want to undo the multiplication of -3 and x. So I divide both sides by -3. -3 divided by itself is 1. 1 times x is x. And then 3 divided by -3 is -1. So we now have a value for x. And we would, at the end of this, make sure you write your answer as an ordered pair because solutions to systems of equations are ordered pairs. So we would write our answer as -1, 1. And that is the final solution. So you don't have to solve this two ways. I showed you the setup if you wanted to get rid of y, which would be a little bit quicker. But I wanted to make sure you understood how to go about solving one of these systems if you had to multiply both equations by some non-zero constant. Okay, so that is solving systems of equations using the addition or elimination method. In the next video, I think we're going to look at unusual how do they word it? Okay, just special cases here. So they'll sometimes say solving systems with unusual solutions. Here we're just going to look at special cases. So that'll be the next video.